Good day everyone, and welcome to where we are putting together solutions to those math and science problems that we are encountering. This video will be based on the topic of sequences, and we will be doing the past paper questions in CSEC Mathematics over the years May 2009 until May 2013. Feel free to like the video and add comments down below so that we can help you. As we look at the CSEC Mathematics topics, we see that there are 10 of them, and this video concentrates on the last one, number 10, the investigation. The investigation question may be set on any combination of objectives in the syllabus, that is, from the topics stated above from 1 to 9. This question is tested particularly in paper 2 as one full question with 10 marks out of the total of 100. From the 5 years that are analyzed in this video, from 2009 to 2013, all 5 May papers on investigation were based on the topic of sequences. May 2009, number 8, the drawings below show the first 3 diagrams in a sequence. Each diagram in the sequence is obtained by drawing a 1-unit square on each side that forms the perimeter of the previous diagram. For example, diagram 2 is obtained by drawing a 1-unit square on each of the 4 sides of diagram 1. So, we will extract diagram 1, and there are 4 sides. As such, we will get 4 squares. We have them as 4 yellow squares. Let's recall that, of course, any CSEC past paper question will be written in black and white. So our colors are here to help us identify how the pattern is being developed. Now, this question is given on an answer sheet, right, which is a graph paper for us to draw. So it will be easy for us to draw the squares. And let's see how diagram 3 is created. From diagram 2, let's extract that, and from the yellow squares we can see on the perimeter of it, on the edge of it, we were able to develop light purple squares right around. So part A of the question, draw diagram 4 in the sequence. So you can pause the video now and try and draw diagram 4. Right. So given enough time there, let's see how we create diagram 4. From diagram 3, we extract it, again, which will be the white square in the middle, followed by the yellow squares, followed by the light purple squares. And now, on the perimeter of the light purple squares, we draw the blue squares. And that's diagram 4. In part B, complete the table by inserting the appropriate values. So if we look at the table, we have 3 columns, diagram number, 1, 2, 3, 4, which we've all drawn, 10, and then the last one is missing, number of unit squares of each diagram, and they gave us, for the first diagram, 1, which we can tell from our diagram. From diagram 2, there were 5 squares. From diagram 3, there were 13 squares, and so on. And they gave us the pattern for calculating the number of unit squares. For the first one, 1 squared plus 0 squared, 2 squared plus 1 squared, 3 squared plus 2 squared. So now, you should pause the video and try and complete the table. When you're finished, put it back on and check our solution. So our solution, if we look at the pattern, we can see that in the third column coming down, that there's an addition sign. So we continue adding in the fourth, adding in diagram number 10, and adding in the last one. And if we look at the first pattern, first number in that column, 1 squared, 2 squared, 3 squared, and those numbers came from the first column, whatever the diagram number was. As such, we can tell 4 squared, because it's diagram number 4, and 10 squared. Now, how do we get the second number? Let's look at it. It started in the first diagram number, 0 squared, then 1 squared, then 2 squared. So how do we get that? If we look at our diagram number, it is 1 less than that. So in diagram number 1, the second number there is 0 squared. In diagram number 2, the second number is 1 squared. In diagram number 3, the second number is 2 squared. As such, in diagram number 4, the second number will be 3 squared, 1 less. And in diagram number 10, then, it will be 1 less than 10, so it will be 9 squared. And now, we can count our number of unit squares. If we total our column on the right side, 1 squared plus 0 squared, 1 ones are 1, plus 0 is 1. So that is the number of unit squares. In the second diagram, we have 2 squared plus 1 squared. 2 squared is 4, plus 1 ones are 1. 4 plus 1 is 5. In the third one, 3 squared plus 2 squared. 3 threes are 9, plus 2 twos are 4. So 9 and 4 is 13. As such, in the diagram number 4, we have 4 squared plus 3 squared, which is 16 plus 9 is equal to 25. And if we check our diagram 4, which we drew in part A, we should be getting 25 squares in all. Now similarly, let's go to the diagram number 10. 10 squared plus 9 squared, 10 tens are 100, 9 nines are 81. 100 plus 81 is equal to 181. Now in our final row, they gave us the total, which is 421. Now which two numbers, when we square them and we add them together, we will get 421. So there are many ways to solve these questions, and in every maths question we can use many different methods. So the easiest method I found was, let's work out the squares of these numbers. We start with 9 squared, 81, 10 squared, 100, 11 squared, 121, 144, 169, 196, 225, 256, and we can go on. And we're going to add two consecutive numbers. Just like we in column 3, the first one we added 0 squared plus 1 squared, 1 squared plus 2 squared, 2 squared plus 3 squared, 3 squared plus 4 squared for 25, 9 squared plus 10 squared for 181. Then which pair will give us 421? So if we check it, 9 squared plus 10 squared, 81 plus 100 gives us 181. 100 plus 121 gives us 221. The next pair, 121 plus 144, 265. 303, 365, 421, 481. So which pair gave us 421? The pair with 15 squared plus 14 squared. As such, that is our solution for the last item missing in the third column. And if we have 15 squared plus 14 squared, remember you could write it the other way as well. But in this pattern, we are writing the larger number first. So 15 squared plus 14 squared. So what's the diagram number? That is missing as well. So the diagram number will be the larger number, the first number in the pattern, which is 15. May 2010, number 8. An answer sheet is provided for this question, which is actually a sheet of graph paper. So the question says, the diagram below shows the first 3 figures in a sequence of figures. Each figure is made up of squares of side 1 centimeter. Figure 1, we can see I have a white square. And to get figure 2, from the white square, we extract it and we develop the 3 yellow squares around it. So it's going around the perimeter, but not below the base. And then to get figure 3, it will be the same figure 2 extracted, and then we put it another square around the perimeter except for the base again. And those will be represented in light purple squares. Now of course, in the CSEC paper, the questions are given in black and white. Right? I'm using colors here to try and show you that you can recognize how the pattern is developing from figure 1, figure 2, figure 3, and so on. So part A, on your answer sheet, draw the fourth figure, figure 4 in the sequence. So in order to develop figure 4, we draw figure 3 over, and I'm using the colors so you can see it. It started with a white square in the middle, followed by 3 yellow squares around it, followed by 5 light purple squares around it. And now figure 4 will mean we're going to get those light blue or light green squares around it from there. Part B, study the patterns in the table shown below and on the answer sheet provided. Complete the rows. So let's take a look at the 3 columns. We have the figures, figure 1, 2, 3, 4, 5, 15, and n. N will be representing any number. The area of the figure, which is in centimeters squared. The perimeter of the figure, the distance around. As such, we need to figure out what is happening for figure 4 and onwards. So if we look at the pattern, we can tell that there's a multiplication for 1 times 6, 2 times 6, 3 times 6. So we can keep multiplying and put that multiplication straight down. And similarly, we have subtraction. So we can subtract for row 4, 5, 15, and n. And there's a 6 that's constant in the pattern. So we'll have 6, 6, 6, 6. And of course we have 2's as well, which is constant. So we'll put the 2 down. So what I'm doing is I'm actually filling it out vertically downwards. As we see the pattern coming down, we just continue with it. Right. And of course there's an equal sign because we're working out this for each one of them. So let's see. We have 1, 2, and 3 as the first number in the pattern. That's the only thing that's been changing. And where is the 1, 2, and 3 coming from? It's coming from which figure it is. 1, 2, and 3 in the first column. As such, for figure 4, therefore the first number will be 4. In the next one, the first number will be 5 because that's figure 5. In the next row, the first number will be 15 because that's figure 15. And of course, for the last one, it's n because that's figure n for any figure. So this will be like a general formula for the pattern. And we can solve for each one. So 4 times 6 is 24, take away 2 is 22. And for the next one, 5 6 is 30, 30 take away 2, 28. 15 6 is 90, 90 take away 2 is 88. And n times 6 can be left like that, or we can write it 6n minus 2. And if you notice something about the pattern that we drew, right, as we went from one to another, we can see that the distance kept increasing by 6. So you can check that. You can see it went from 4, add 6 is 10, add 6 is 16, 22, 28, and so on. Now for the area, how are we getting these numbers 1, 4, and 9? We can pick it up from the figure number. Figure 1 has the area of 1 because there's 1 square. Figure 2, the area is 4 because there are 4 squares. So we can say 2 2's are 4, or 2 squared is 4. 3 3's are 9, so 3 squared is equal to 9. As such, for figure 4, it will be 4 squared, which is 16. Figure 5, 5 squared, which is 25. Figure 15 would be 15 squared, which is 225. And we have calculators in our exam, so we can use them. And figure n will be n squared. May 2011, number 8. And an answer sheet is provided for this question as well. The figure below shows the first 3 diagrams in a sequence. Each diagram is made up of sticks joined at the ends by thumbtacks. The sticks are represented by lines and the thumbtacks by dots. Each diagram there are T thumbtacks and S sticks. On the answer sheet provided, draw the fourth diagram in the sequence. So if we look at figure 1, there will be 4 sticks, and for the sticks to be held together, there are 4 thumbtacks. Let's extract figure 1 to create figure 2. What can we see? We can see figure 1 is drawn, and in order to get figure 2, we repeat it. So how many did we add to figure 1? We added 4 more sticks. So there were 4 sticks at first, and we added 4 more. That gives us 8. And how many thumbtacks? We added 3 thumbtacks, 1 less, because the thumbtack in the middle works for both left and right. So let's extract figure 2 and create figure 3. From figure 3, as we try to draw each square in a different color, we can tell that figure 2 is there. And how do we get the extra part? We add 4 more sticks, just as usual, maintaining that pattern. 4 sticks in the first diagram, 8 sticks in the second, 12 sticks in the third. And how many more thumbtacks? 3 more. So we keep adding in 3s because the thumbtack is repeating for both the second and third squares. So how do we create the fourth diagram? Well, we repeat figure 3, and now we add 4 more sticks and 3 more thumbtacks. Part B, part 1, how many sticks are in the sixth diagram? So each diagram has 4 sticks. As such, in the sixth diagram, there will be 6 times 4, which is 24 sticks. And in part 2, how many thumbtacks are in the seventh diagram? So let's recall, in the first diagram, there were 4 thumbtacks. And in the second diagram, we added 3 more, and in the third, 3 more, and in the fourth, 3 more. So there were 4 thumbtacks in the first diagram and 3 more in every other diagram. As such, 4 plus, how many more diagrams there will be? 6 more. So 4 plus 6 3s are 18s. 18 and 4 is equal to 22 thumbtacks. Now, part C, complete the table by inserting the missing values. So we can see that there are 3 columns: number of sticks, S, the rule connecting T and S, and the number of thumbtacks, T. And they give us the information for the first 3 rows, meaning, and I'm going to add another column so we can understand it a little better. In the first column there, I'm adding diagrams. So diagram number 1, 2, 3, and so on. As such, we can tell that in diagram 1, we drew 4 sticks. So there were 4 thumbtacks. In diagram 2, there were 2 4s at 8 sticks. So there were 7 thumbtacks, 4 plus 3. In diagram number 3, 3 4s are 12. There were 12 sticks. And as such, there were 4 for the first, and then 3 thumbtacks for each of the others. So 4 plus 3 is 7, plus 3 is 10. Now they're giving us a rule to connect it, which will also help us solve it a little quicker. So in the fourth row, there were 52 sticks. As such, the diagram would be 4 divided by 52, which is 13. So that information they're asking about would be for the 13th diagram, where there are 52 sticks. Now, let's look at the pattern coming down. There's an addition, addition, addition. So let's put 2 more in the next 2 rows. There are multiplication signs, 3 of them coming down. So let's continue downwards with the multiplication for the 4th and 5th rows. The first item is 1. So we can add 1 in each of them. And there are open and closed brackets, open or parentheses. So we can add those. And there's the number 3/4. So as such, the only thing that's changing in the pattern would be the last number, which is 4. in the first row, 8 in the second row, 12 in the third row. So where are they getting those numbers from? They're getting from the number of sticks. So in our fourth row, where we have 52 sticks, then it would be 1 plus 3/4 times 52. And we can use our calculator and solve that. Of course, 4 into 52 is 13, 13 3s are 39, 39 add 1 equals to 40. And in our last row, they gave us the number of thumbtacks, 55. And we needed to work backwards to get the number which is missing, which is S. So let's see. 1 plus 3/4 times S, because we don't know what it is equal to T. That is our formula. And they gave us T. T is equal to 55, so we can substitute. So we have 1 plus 3/4 times S is equal to 55. And if we want to solve for S, we need to get rid of all the items on the left-hand side of the equation. So the first thing we get rid of is the 1. The 1 is adding. So when we carry it across onto the other side, it means we're doing the additive inverse, or we're subtracting. Easier to see. So we get 3/4 times S is equal to 55 times, take away 1. 3/4 times S will give us 54. So if we want S alone, we can take the 3/4, which is on the left-hand side, and move it across. The 3 is on the numerator above, it's multiplying. When we carry it across, it will divide. And the 4, which is below in the denominator, is dividing. So when we carry it across, it will multiply. As such, we get S is equal to 54 times 4 over 3. And we can use our calculator and solve here. Or 3 into 3, 1, 3 into 54, 18. 18 4s are 72. As such, in this diagram, in order to figure out how many sticks we have, the sticks would be 72. And thus, the rule connecting them in the middle will be 1 plus 3/4 times 72. May 2012, number 8. The diagram below shows the first 3 figures in a sequence of figures. Each figure is an isosceles triangle made of a rubber band stretched around pins on a geoboard. The pins are arranged in rows and columns 1 unit apart. On the answer sheet provided, draw the fourth diagram in the sequence. So, let's look at diagram 1. In that isosceles triangle, the base is 2 units wide and the height is 1 unit. So let's extract that and look at figure 2. In our second diagram, we can see that the base moved from 2 units to 4 units wide, and the height moved from 1 unit to 2. By the third diagram, let's extract the second and let it expand, and we can see that the base moved from 4 units to 6 units, and the height moved from 2 to 3 units. So the progression is height moved from 1 unit to 2 to 3. So that means in diagram 4, the height has to be 4 units. And the base moved from 2 units to 4 to 6. As such, diagram 4 should be 8 units. In part B, study the patterns in the table below and complete the rows. The breaks in the columns are to indicate the rows do not follow one after the other. So you should pause the video now and attempt to complete the table. So let's do the solution. If we look at the figures here, we can see that the figure 1, the area of the triangle is 1. And for figure 2, the area of the triangle is 4, which means we can see that 1 squared is equal to 1, 2 squared, 2 2s are 4. For figure 3, following that pattern, 3 squared, that will be 3 3s are 9. So for figure 4, what would the area of the triangle be? 4 squared, which is 16. And for the next row, they gave us the area of the triangle, which is 100. So what number, when squared, will give us 100? Well, we can find the square root of 100, and that will be 10. And for the next row, for figure 20, so we're extrapolating the concept. for the 20th figure. And the area of that triangle would be 20 squared, which is 400. Remember, you have your calculators in this examination, so you can use them. And if it was for any number, it doesn't matter what number it is, then for that figure, we'd call it n, and the area of that triangle would be n squared. Now let's look at the number of pins on the base, which was held on the geoboard in order to make the triangle. So if we look at the first three rows, figure 1, 2, and 3, we should be able to pick up a pattern. And that sequence is that there's a 2 as a first in each. So let's put a 2 in each one of those rows coming vertically downwards. And then we have a multiplication sign that's consistent. So let's put multiply straight down. And then we have the numbers 1, 2, 3. This is what is changing. And where are we getting these numbers 1, 2, and 3? From the first column, from the figure. As such, for the figure 4, then we'll be putting in a 4. For the next one, we'll put in a 10 because that row is figure 10. For the next row on row 20, that will be there. And for n, well, of course, we'll substitute an n. And what follows? An addition sign coming down. And then number 1 coming straight down. So that will give us an equal sign. And the equal sign will give us, for the first one, 2 4s are 8, and 1 is equal to 9. 2 by 10 is 20, and 1 is 21. 2 by 20 is 40, and 1 is 41. And we can rewrite the last one if you want, or leave it as is, which is 2n plus 1. May 2013, number 8. The drawings below show the first 3 diagrams in a sequence. Each diagram is made up of wires of equal length, which are joined at the ends by balls of plasticine. Diagram 1 is made up of 12 wires and 8 balls. Each new diagram in the sequence is formed by fitting the frame shown below to the right of the previous diagram. So we can see from diagram 1, in order to form diagram 2, we extract diagram 1 and we add that pattern. And that gives us diagram 2. And to give us diagram 3, then we extract diagram 2 and we add that pattern again. And of course, how do we get diagram 4? We redraw diagram 3 and add that pattern once more. In part B, complete the table by inserting the missing values at the following rows. So if we look at the diagram, we can see the first column, name of the diagram, diagram 1, 2, 3, and 4 and 20, and we drew diagram 4. Number of wires, 12, 20, 28, so you can see they're increasing by a constant amount. Number of balls, 8, 12, 16, and so forth. So we should be able to fill out rows 4 and 20. Now, if we try to pick up a pattern from here, let's work a little backwards. If we're coming downwards in the number of wires, from 12 to 20, we increase by 8. And from 20 to 28, we also increase by 8. So we can see as we move from one diagram to another, the difference is 8. So if we go backwards from 12, let's say there was an initial point, then we would be minusing 8 from 12. And that would give us 4. So let's use that 4 to help produce a pattern. So if we start with 4 in diagram 1, it will be 4 plus 8 will give us the 12. In diagram 2, it will be 4 plus 8 plus 8, which will give us 20. And in diagram 3, we're adding 8 again. So it will be 4 plus 8 plus 8 plus 8. And as such, in diagram 4, it will be 4 plus 8 plus 8 plus 8 plus another 8. And that will give us 36. So let's see if we could write that a little easier. So in the first diagram, we could say 4 plus how many 8s do we have? 1 8. So 4 plus 1 times 8. In the second diagram, it will be 4 plus 2 8s. In the third diagram, it will be 4 plus 3 times 8. And as such, if we follow the pattern, we can see that the 4, the plus, the brackets, the multiplication, and the 8 all remain the same coming down vertically. And what is changing is the numbers 1, 2, 3. And we can see those identical numbers are the numbers used in N, diagram number. As such, for diagram 4, it will be 4 plus 4 8s. And we can confirm, if we solve that, 4 8s are 32 and 4 is equal to 36. And let's move on to diagram 20. So diagram 20, by following the pattern, will be 4 plus 20 times 8. And 20 times 8 is equal to 160 plus 4, which is equal to 164. So for any diagram N, it will be 4 plus N times 8. And that will be equal to W, the number of wires. So now let's look for a similar pattern in the third column in the number of balls B. So in diagram 1, it is 8. In diagram 2, it is 12. So it increased by 4 by adding 4. In diagram 3, it is 16. So 12 add 4 is equal to 16. So for each diagram, there's a difference of 4. So if we go backwards from 8, let's invent one. If there's a diagram 0, let's say, then it would be, we'd be subtracting 4. And that will be 8 take away 4 is 4. So let's say we had an initial diagram of 4. And how do we increase? We go 4 plus 4 for the first diagram. 4 plus 4, which is 8, and another 4, that's 12 for the second diagram. For the third diagram, 4 plus, and we keep adding 4s. We have 3 of them, so that'll give us 16. And then, of course, for the fourth diagram, 4 plus 4 plus 4 plus 4 plus 4. As such, if we look at that, we can see we have a pattern in which for the first diagram, we had how many 4s? 1 plus 1 and 1, 2 4s. And that would give us 8. And for the second diagram, we had 3 4s. And that would give us 12. And for the third diagram, 4 4s. Right. So we can see how is the pattern changing by the number that we are multiplying the 4 by. It was 2, 3, 4. So how is that? How can we recognize that sequence? It's coming from the first column, and whatever number there's in the first column, we're adding 1 to it. As such, for the fourth diagram, it will be how many 4s? It will be 4 plus 1, which is 5 4s. And 5 4s will be 20. And if you check our fourth diagram that we just drew, we should have 20 plasticine balls. So, by following that format, what happens in the 20th diagram? We will have 20 plus 1, which is 21 times 4, which is equal to 84. And if there's for any diagram N, and let's create a general formula, then it would be N plus 1 times 4, and that will be equal to B. We've now come to the end of this video, which dealt with the past paper questions on the topic of sequences, which falls under investigation, from the years May 2009 to 2013. We will now be creating another video following the next 5 years, from May 2014 to 2018.